Hello and welcome to section 7.2, which is on similar polygons. So if you recall from previous classes that you've taken, similar means same shape but not the same size. Similar polygons is when corresponding angles are congruent, and if the lengths of the corresponding sides are proportional, then they are similar. So the angles, all the corresponding angles have to be equal, and then all of the side lengths, the corresponding side lengths have to be proportional as well. Otherwise, it is not similar. Extended proportion is when three or more ratios are equal. You can write them in a proportion, and I will give you an example here. So if I have A over B, G over H equals B over C, HI equals CD, IJ equals AD over GJ. It's still a proportion as long as all those things are equal. When we think of a proportion, we usually just think of two fractions that are equal to each other, but it doesn't have to stop at just two. Scale factor is a ratio of corresponding linear measurements of two similar figures. So how much bigger or smaller the similar figures are. So if they're twice as big, then your scale factor is 2. If they're a fourth as big, then your scale factor is 1/4. Depends how big the original figure is and how big the one is that you are scaling down or scaling up. So from my example here, I have DEFG similar to HJKL. What are the pairs of congruent angles? And we've done this. We did this in chapter 4, where we had to match up the sides or the angles. So angle D equals so here are the angles that are equal to each other. Angle D equals angle H, and if you just look at the congruent statement here, D and H match up E and J, F and K, G and L. That's where I got these from. We've done that before. So what is the extended proportion for the ratios of the lengths of corresponding sides? So now you're looking at the sides and trying to figure out, well, how does that match up? How do the sides match up? And how can I write that in a proportion? So if I just start with side DE, what would it match up with on the other one? HJ. So you've got to go through and do all the sides. So then I'm just going to go down the line, and I'm going to go EF, and that matches up with JK on the other one. Then I'm going to do FG, and that would match up with KL. And I have one side left, which is the first letter and the last letter, so DG and HL. Just make sure that you match them up correspondingly. If you start at the beginning, then start at the beginning on the other one, just like we did in chapter 4 when we were writing all of our congruent statements. Similar thinking, but you're going to write it as proportions. Another example, are the polygons similar? If so, write a similarity statement and give the scale factor. So I obviously can tell all the angles are right angles, so I don't have to worry about that. The first thing you do have to look at is, are all of the corresponding angles congruent? And they are in this case. Then I need to look at the side lengths. So 15 right here over 15. And I need to see, is that equal to, if I started with this big one first, then I need to start with that one first the second time. So 20 over the 10 here. And you can see that that's obviously not equal. This is a ratio of 1 to 1, and this is a ratio of 2 to 1. So not similar, so I don't need to do the rest of it. If they were similar, I would just reduce it, and that would be my scale factor. So another example says use the diagram to find the value of y. And there's a lot going on in this diagram, but if you just kind of work your way through it, it'll be fine. So the first thing I need to do is figure out which numbers I can use to figure out y. And so I have a portion, I have this smaller side here, and I also have the bigger side, which I wrote out here so that it wouldn't be confused in there. So I have 6, which is the shorter side, to 9, which is the longer side, And then this side, since I started with a smaller figure, I need to put that on top, and that corresponds to this side, which is 5. And then if I just go ahead and solve that, I should be able to get what y is. So crisscross applesauce, just like I taught you in junior high. So 9 times y, 6 times 5. Divide both sides by 9, and I can reduce that by 3. So 10 over 3 equals y. Or you could change it to a mixed number and say 3 1/3 equals y. Same thing. So using your proportion to solve what's missing. We've done similar things like this before. Scale drawing, all lengths are proportional to their corresponding actual lengths. We did some of this in junior high as well, where we had to draw out our bedrooms, and we also had to draw out our scale drawing of the dream room that we built proportionally. The scale is the ratio that compares each length in the scale drawing to the actual length. So that's the scale that you're using. How big or how much smaller are you making it is what you're looking for the scale. Is it half as big? Is it a fourth as big? Is it 1 inch equals 10 feet? Whatever your scale is. For my example, you want to make a scale drawing of New York City's Empire State Building using the scale of 1 inch to 200 feet. Excuse me, 250 feet. So if the building is 1,250 feet tall, how tall should you make the building in your scale drawing? You can go ahead and set up a proportion for this. So if I know that my scale is 1 inch to 250 feet, and I don't know how many inches I need to make it, but I do know that the real thing is 1,250 feet tall. Now I just have to solve this. So 1 times 1,250 is still 1,250. 250 times x is 250x. So then really all I need to do is take that 1,250 and divide it by 250. The 250 is going to go in there 5 times, so 5 inches equals my x. So 5 inches tall is how big I need to make it on the drawing, so that it is proportional to my original scale that I gave you right here, 1 inch to 250 feet. And there's all kinds of different ways that you can use this information, and we will look at it more the next time I see you. Have a good night.